Here now we start lecture number 6, which is a very important according to group 14 carbon family. So now we continue with carbon family. Okay, now here group 14 elements. Just to continue this lecture number 6. Okay, unit 11 group elements. And this is the last group 14 elements, the carbon family. Why it is called carbon family? Because first member of this group 14 is a carbon, then it's followed by silicon, then it's followed by germanium, then it's followed by tin, that is Sn, and then it's followed by Pb. So how you remember this? Pb means lead. Okay. Ka means carbon, C means silicon, G, Ka, C, J, T means tin, and lead means lead. Ka, C, J, T, lead. That's what you remember. Or in different way, Kasi Germany sun padke. Okay, Kasi Germany sun padke, or say padkare. Okay, that's it. Or Kasi Germany sun padkare. Okay, that's what you remember. So this is the way. And first member of this group 14 elements is carbon. So here it is a very interesting, you know this one. Carbon is very useful. You know, you already learned chapter number 12 and 13, in which organic chemistry deals with carbon. So you know many compounds. Okay, so this carbon is a 17th most abundant element by mass in Earth's crust, widely distributed in nature in free as well as in combined state. That means in a free nature as well as in a combined state. Elemental state. In elemental state, this carbon is obtained as coal, graphite and diamond. You know this one? Coal, graphite and diamond. And combined state, we can say that metallic, that is a metal carbonate, another hydrocarbons. Suppose I write it here. So you know this one: methane, ethane, propane, butane. Many things you know. All organic compound which is made up of carbon and hydrogen that deals with this particular hydrocarbon compound. So here we write CnH2n plus 2. It is not enough. CnH2n, CnH2n minus 2. Many compounds are there. C6H6. Okay. This type all compounds we are familiar with a particular this carbon atom in a chapter 13 and 12. So here CO2 gas. CO2 in a air, we can say 0.03%, 0.03% in a air. Okay. Carbon is the most versatile. It is a required versatile element in the world. Without carbon, you can't learn anything. Carbon is the most versatile. Remember, versatile element in the world. It necessity. It's required. So it's very important. It combines with dihydrogen, dichlorine, oxygen, and sulfur. Provides an astonishing array of materials ranging from living tissues to drugs and plastics. You know that all drugs or say plastics, if there is carbon or hydrogen may be present. So carbon and hydrogen is required. In living tissues also carbon is required. Okay, so these all terms are very important that you are familiar with particular. We can say that astonishing array of materials. Ranging, astronomist, if we speak that way, array of materials ranging from living tissues to drugs and plastics. In organic chemistry, you know that it is the most important compound. Okay, without this carbon, we cannot learn anything. So you remember this one. This organic chemistry deals with carbon, and carbon is very important in the form of carbonate, bicarbonate. Okay, many forms are there. Okay, carbonate form is there, bicarbonate form is there, carbon dioxide form is there, carbon monoxide form is there. This all terms you have to remember, and it is a very important. In organic chemistry, you learn many organic compounds. They are formed with the help of carbon atom. So here it is very important. Isotopes means what you know that. So here C12, C13 and C14. This type of isotopes is observed, and C14 is considered as radioactive element or say radioactive carbon. Those half-life period is 5770 years. Remember this half-life a radioactive element is there, or radioactive carbon is there, that is C14, and which is a very important in a, we can say, chemical kinetics, to know particular aging that you have to learn later on. Don't bother, aging of any ancient material, okay, any old material. If you know the age of that particular material, it is observed with the help of this radioactive carbon. So it's very important. So this carbon is very important. Just you read it all the topic regarding this carbon atom. Okay. Now next one is silicon. Silicon is a second abundant, that is 27.7 by mass, most abundant element on the earth crust. Second most abundant element. I am not speaking metal. Metal is aluminium. But second most abundant element on earth crust is a silicon. So remember this one. Present in the form of silica and silicates in nature. It is present in the form of silica. Silica means, you know, that sand. Silicates, different types of material which is prepared from silicon dioxide, SiO2, with respect to silicates in nature. Okay, present in nature in the form of silica and silicates. Important, you know, these are silicates means what? Ceramics is there. Cup is there, cup of tea, and that cup is made up of ceramic, and that ceramic is nothing but, we can say, it is made up of silicates, or say silicon. Okay, and this silicon, very, you know this one, it's a very important nowadays. In a computer chips is there, it is made up of silicon. So it's also once again important. Important component of ceramics, glass and cement. Very important. Important component of ceramics, glass and cement. You already learned SiO2 we have to add for, we can say, that good quality cement. Okay, it's very important. And germanium. Germanium exists only in trace, very rarely. So very rarely is observed in a, we can say, nature in a trace. So this germanium and tin. Tin is a cassiterite. Cassiterite, SnO2. Name you remember. Cassiterite formula is SnO2. And lead. Lead means Pb. It is known as plumbum. It is known as plumbum, and that's why we write Pb. Galena. Galena is a, we can say that it is obtained, plumbum, which is obtained from PbS. Galena. So remember, and this one in your NCERT textbook, once again another sentence is written, which is very important. Silicon and germanium, they are considered as semi-metals. That's why they are used in a semiconductor and transistor. Okay, in transistor, you know that in radio, TV, this type of, we can say that you observed certain material, or say we can say that enhancement instrument, in which we can say that you use silicon and germanium as a semiconductors, that you have to learn later on. Okay, physics, and others it is like transistors. Okay, transistors. Okay, it is used in making transistors. So this is all about the group 14 elements: carbon, silicon, germanium, tin and lead. Sequence you remember. First of all, we learn here. Now later on we learn here electronic configuration, covalent radius, ionization enthalpy, and so on. So just you write it completely from your NCERT book, and this is a topic regarding occurrence. Okay, occurrence. So just you write it completely, and here whatever the carbon is there, it's very important. Silicon is very important. Germanium, tin, lead. This cassiterite, SnO2, and this galena is PbS. This you must know, and it's a very important. Okay, so you write it completely according to your NCERT textbook. Now we just switch on towards electronic configurations and different trains in group 14, or say the carbon family. Okay, now here group 14 elements is there, and the general electronic configuration in outer, you can say itself, is NS2, NP2. Remember, in NS just you see 2 electron is there. Okay, in NP 2 electron is there. That means you have to remember here electronic configuration very easily. First of all, write down first member of carbon family is carbon. Atomic number is 6. Silicon atomic number is 14, germanium atomic number is 32, tin atomic number is 50, and lead atomic number is 82. Once again, Ca, C, J, T, lead. Once again, Ca means carbon, C means silicon, J means germanium, J, T means tin, Tin, and its symbol is Sn. Lead means lead, Ca-C-J-T, lead. Okay, Ca-C-J-T, lead, or say tin lead, Ca-C-J, tin lead. That's what you remember. And here, remember this very important magic number. Suppose we write here 8, so 6 plus 8 is equal to 14. 14 plus here we write 18, that is nothing but 32. 32 plus 18, that is 50, and 50 plus 32 is 82. So this is electronic VKSLA configuration. First of all, you have to remember atomic number. Okay, and atomic number indicate number of protons as well as which is present in a nucleus, as well as number of electron which is outer side of the nucleus in a orbit. So here 6 is there, so He core 2s2 2p2. This is a simple electronic configuration. Why we write this He core, Ne core? Because we can write, we are prevented from writing 1s2 2s2 2p6, and that's why we write Ne core, Ar core, and that substance is completely filled. Okay, and that's why He 2s2 2p2, Ne core 3s2 3p2, Ar core 3d10 4s2 4p2. Krypton core 4d10 5s2 5p2. Xenon core 4f14 5d10 6s2 6p2. Once again, this same traits observed at here. This is considered as lighter elements. This is considered as heavier elements. And from that, you have to identify when we move. So it is very important to know when we move top to bottom, that means carbon electronic configuration to lead at a time in a valence cell, increasing cells, SHELL cell. Okay, and that's why we can say that here principal quantum number is increased, and that's why they are far away from the nucleus. But you know that poor shielding effect that you already learned in group 13, that is also take part. And another, why there is variation is occur, inert pair effect, poor shielding, you remember these two words, and screening effect. These words must you remember, and therefore you write down here electronic configurations according to this way. So He core 2s2 2p2, Ne core 3s2 3p2, Ar core 3d10 4s2 4p2. First of all, electron enter in a 4s, then 3d, and then in a 4p. Another krypton core 4d10 5s2 5p2. First of all, electron enter in 5s, then 4d, and then 5p. Xenon core. So first of all, electron enter in a 6s2, then 4f14 is completely filled, then 5d10 is completely filled, then they enter in 6p2, and that's why here poor screening effect is occur. So remember this one. D orbital and F orbital are known for poor screening effect. They are attracted towards the nucleus, and here we can say that maximum screening effect, strong screening effect is occur, and due to that we can say that they are repelled from nucleus. So effective nuclear charge increases in a heavier matters, or say heavier elements, not matters but heavier elements, and you have to observe these things in a different trains, just like covalent radius and ionization enthalpy. So just to write down this electronic configuration. Now here covalent radius, just to see these trends. Here carbon at covalent radius is 77, silicon covalent radius is 118. That means it is increases from carbon to silicon. But just to see silicon to germanium, this 112 is there and 122 is there. Now it is an increase, but now it is a decrease. Okay, and then just to see it is an increase. Once again, it's a very simple. Actually, atomic radius, or say we can say that covalent radius is there. It's depend on particular, we can say that size. Here just you see 77 is there. That means here this 2s orbital which possesses more screening effect, and that's why here 77 picometer, and here also same way 3s2 and 3p2 is there, and s and p orbital they are producing strong, we can say that screening effect, shielding effect, and that's why here the size or say covalent radius is increases. But just you see here, no in 3s, 3p, 2s, 2p there is no any d and f orbital is present, but in germanium, tin and lead they followed by d and f orbital, and that's why just you see 122, 140, 146. So here it is increases due to, we can say that here least or say less screening effect due to d orbital and f orbital. They are completely filled, okay, and that's why they attracted towards the nucleus, and due to that we can say that this covalent radius once again increases. But here decrease due to which particular factor? There is a no d and f orbital is present, or say d orbital is present. So this is all about covalent radius. Now we switch on towards ionization enthalpy. So write it completely. So just to see here, according to your NCERT textbook, the first ionization enthalpy of group 14 is more than, okay, members is higher than the corresponding members of group 13. It's a correct, because as you observe this 1086 value is very high. And here the influence of, just you see, covalent radius is 77, at that time ionization enthalpy is 1086, and then 786. That means whatever the trend is there, it is decreases. And once again you see 786 to 761, which is a very little decreases, once again little decreases, and then just to see increase. This is due to poor screening effect. You know this topic, you already learned. Another name is inert pair effect. Inert pair effect. Due to that, we can say that here ionization enthalpy is increases 708 to 750. So this is we can say that first ionization enthalpy, second ionization enthalpy. Just you see in your table number 11.3. So delta IH1 for removing one electron from outer cell here, and another delta IH2, it is the second ionization enthalpy, removing second electron. Then delta IH3, then delta IH4, because in valence cell 4 electron is there, and that's why here fourth ionization enthalpy is also introduced. And this fourth ionization enthalpy value is, just you see, 6220, 4354, 4409, 3929, and 4082. So this much value, that means it is a decreases. So according to, we can say that here 2s2 and 2p1, whatever the orbital is there, they are removing their electrons, and according to this delta IH from Si to Ge, that is germanium to silicon, and slight increase in delta IH from just its organism tin to lead, it is increased due to, just you write it completely, consequence of poor shielding effect intervening. Just I explained it in poor, we can say that screening effect due to presence of 4f and 5d orbital, and they attracted towards the nucleus, and that's why we can say that there is a poor screening effect occur, and that is the thing. But inert pair effect, that topic you already learned in just group 13 elements. That same result is observed here, and due to that we can say that poor shielding effect intervening. Intervening means what? This 6s2 and 6p2, intervening is 5d and 4f. So first of all entering 6s, then 4f, then 5d. Okay, so this is considered as intervening. Okay, intervening d and f orbital and increase in size 140 to 146, and that's why here 708 to 750. So somewhat at a covalent radius is increased. So here ionization enthalpy is increased due to, you have to write it, poor screening effect. So complete it and write it from your NCERT textbook. Just you observe your table number 11.3. Okay, so this is all about ionization enthalpy. Now last topic is from this electronegativity. Just we learn here. Here in a period when we move from 13 group to 14 group, it is a, we can say that atomic size is a small. So here sentence that due to small size, the elements of this group are slightly more electronegative as compared to group 13. Underline on this, the electronegative values for elements from silicon to lead is almost the same. Just you see 1.8, 1.8, 1.8 or 1.9, and here carbon possesses very atomic size less, and that's why it's a 2.5. So you have to remember this one. Electronegativity traits is just not it's just like similar 1.8, 1.8, 1.8 here and 1.9. Okay. So here your electronegativity also complete. Now we switch on towards physical properties, and this is your last topic of this particular lecture number 6. Write down according to electronegativity traits. Now we have physical properties. According to physical properties, all elements are in a solid form of group 14 elements. Carbon and silicon, they are non-metals. Germanium, they are metalloids. And tin and lead, they are soft metal with low melting point. Okay. Melting point and boiling point of group 14 elements are much higher than those of corresponding elements of group 13. That you already just you observed in your, we can say that tabular form. So this is all about here physical properties of group 14 elements. Here it is written. Now we in the next lecture switch on towards chemical properties. So here lecture number 6 is complete. So write it completely. Remember electronic configuration. Remember certain traits. Remember overspinning effect, where it is occur, where strong we can say spinning effect is occur, and due to that here carbon, silicon, germanium, lead is there. So this carbon is making a covalent nature. So they are just this 2s orbital containing 2 electron entered in a 2p, we can say that z orbital, and that's why 2s 2p all orbital is containing 1 unpaired. So valency of this carbon atom is 4. You already learned CH4, and that's why you have to learn it here. And then it is due to, we can say that here spinning effect is occur. So it's a repel, and due to that this 2s2 containing electron entered in a 2pz orbital. And this ionization enthalpy is just to see it's very increasing, also very high. 1086 is there, and due to that we can say that they form C plus 4 as well as C minus 4, both type of, we can say that, compound. So this is all about, we can say that here electronic configurations NS2 and P2. And here most important thing, NS2 and P2 is there. That means outermost orbital or say outermost or say valence shell, they containing NS2 and P2. Last electron enter in a p orbital. Okay, so these are all about. And carbon form allotropes also. They form 3 types of allotropes that we learn later on. That is first is we can say that diamond, then graphite, and then fullerene. So it's a very important. They form allotropes due to, we can say that, physical properties. Different here you have to learn later on. Silicon is also very useful. So this is all about here physical properties of group 14. You write it from your NCERT textbook. Thank you very much.